Now we'll enter into the fourth unit, that is basically related to the digital electronics. Okay, and here the terminology whatever we are going to see in the fourth unit, this is quite opposite to the topics what we have seen previously. Now this fourth unit is completely related to digital. Okay, so the first topic what we are going to see in the module 4 is a binary number system. Okay, so it will be easy only. So binary is nothing but 2. Okay, what are those two means? Symbol 0 and symbol 1. And generally in our daily life we are using the decimal number system. Decimal number system means 10 different symbols we are using for counting the numbers like that. Okay, for counting the cash also we are using the decimal number system only. In our daily life we are using the decimal number system. Decimal means 10 will be there. So 10 different symbols we are using. So decimal number system means 10 different symbols we are using starting from 0 to 9. We know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 different symbols we are using to represent any number. For example, 0 to 9, these are the symbols we will use. If you want to write 10, we are using this 1 and 0 only. And if you want to represent any other number, we need to take from this set of 10 symbols only. For example, 1,59,324 is there. All these symbols are available in this particular set of 10 symbols only. Okay. So, to represent any number, we are using 10 symbols. So, that's why it is coming under the decimal number system. In our daily life, we are using this decimal number system only. Now, contrary to this one, we are going to see here binary number system. For the digital electronics, digital part, we will use generally this binary number system only. So, as I said earlier, binary means only two different symbols we are using. Okay. For example, I have 15 pens. Okay. To represent that 15 pens, I need to use the symbol 1 and I need to use the symbol 5. Count is not changed. I am saying here 15 pens are there. That 15 pens we can represent in the decimal number system like by using this symbol and by using this symbol. I will write like this 15, 1, 5. Because we are studying here another number system, just to differentiate that one, I am giving here base 10. This is the base 10 is representing that this 15 is to be read in decimal number system. But the same number of pens, okay, I am not changing the number of pens, number of pens are 15 only, and that number of pens I am representing using the symbols 1 and 5 in the decimal number system. But without changing the number of pins, I can able to represent that one in the binary number system also using the symbols 0 and 1 only. The same 15 number of pins I need to represent, like 15 is nothing but, we can able to treat this 15 in decimal can be representing as 1111 in the binary. You see, 4 ones if you take, this is actually equivalent to this 15 only. Okay, 1111 number of pens are available on the table. In the binary number system, I have represented that 1111. But 15 in the decimal number system, I need to represent that same set of 15 pens. I need to represent using 15. That means 15. Okay. But the quantity is same. Whether you are representing in the binary number system using 1111 or you are representing in the decimal number system using the symbols 1 and 5, same number of pens we are representing. Okay. But how we are representing, that is different. It is like a different language. So, in different language we are representing how many pens are available. That one we are telling. This is one language called decimal number system. This is another language called binary number system. Okay. So, mainly our focus will be on the binary number system now. And what are the other number systems? So, what are the conversion from the binary to decimal, decimal to binary, and binary to hexadecimal, hexadecimal to binary. Like this, we will see the topics related to in this particular chapter. Okay. This is a little bit introduction to the binary number system, and conversion between the binary and decimal also we are going to see in this particular module. Now, what is the binary number system? So, binary is a number system with the basis 2. Okay, already I have mentioned about that one, and the symbols or the digits used are 0 and 1. To represent any number of any quantity, we need to use here only two symbols only, 0 and 1 only we have to use, and we can represent whatever the quantity of pens are there or whatever the number we need, that any big number also we can represent using the only two symbols like zeros and ones only. Any number of times you can able to take zeros, you can take any number of times, ones you can take any number of times, in position of zeros and ones also you can able to change. But whatever the quantity is there, that entire quantity will represent in terms of zeros and ones only. Okay, and use it in the digital electronics as I said earlier, and in the computers also we will use this particular binary number system only. Next, place value in the binary. You see here each digit, that means a bit also we can tell, each digit represents a power of 2. Okay. As it is a binary number system, it is the power of 2. If it is octal number system, it is the power of 8. If it is hexadecimal number of system, then it will be the power of 16. If it is decimal number system, it is power of 10. So, as we are discussing with respect to binary, each digit is representing the power of 2. If you see the example, here one example is given, that is 1011, and the suffix 2 is representing, as I said earlier, it was given in the binary number system. So, it is 1011 means, so you should not think it is the 1011. It is 1011 by default when it is in the decimal number system, but here suffix 2 is given. So, you should not read this one like 1011. It is 1011 only. It is not representing the 1011 in the decimal number system. Some certain value is there in the this binary number system. It is approximately 11, that we will check now. So, how to convert? Here conversion is also I am going to tell here. So, how to convert this one into the decimal number system? That is that part we are going to see here. And as I said earlier, each digit or each bit is representing the power of 2, and we need to take that one from the right hand side onwards. So, this one is representing certain power of 2, it is also representing power of 2, it is also representing power of 2, it is also representing the power of 2. We need to start from right hand side to towards the left side. Okay, and we need to start the powers like 2 power 0, 2 power 1, 2 power 2, 2 power 3, like that we have to take. So, how to represent this one means, now carefully you see, whatever the starting one is there, that one is representing the power of 2, that is 2 power 0. So, this is the amount of quantity is represented by this 1. Okay, that is the weight. The digit is 1, and what is the weight of that particular digit is nothing but 2 power 0. With that weight, we need to multiply that particular digit. Now, another digit is 1 is available. Because it is available in the next position, the weight related to this one is 2 power 1. Already 2 power 0 is over. So, the weight related to this one is 2 power 1. So, 2 power 1 is the weight of this one, and I have multiplied that weight with this one. So, I got like this. Okay. Now, this is the 0 and it is available in third position from the right side. So, first one is 2 power 0 is the weight, 2 power 1 is the weight, 2 power 2 is the weight. So, with that weight, if you multiply that 0, we will get like this. Okay. Next, last one is 1 is available, and it is available in the fourth position, so that its weight will be 2 power 3. So, 1 into 2 power 3 is a value we are getting by multiplying with its weight. Now, all these things we have to take a summation, that means addition, like this we have to take. So, this 1 is related to this part, this 0 is related to this part, this 1 is related to this part. Okay. So, what I have done here, I have taken the summation of all the digits with the multiplication of their corresponding weights. This one weight is 2 power 0, this one weight is 2 power 1, this 0 weight is 2 power 2, this one weight is 2 power 3. So, I have multiplied these digits with their weights and I have taken the total summation. What we will get, you see carefully here. So, it is equal to 1 into 8, 2 power 3 is 8 plus here 0 into something is 0 plus this 1 into 2 is nothing but 2 I will get, and this 1 into 2 power 0 is 1, that means 1. So, it is equal to 11. This 11 is already converted into now decimal. So, this is a way of conversion from the binary number to this decimal number. So, because we are working with the number of this number system, so that's why for this decimal number system also you try to represent a base is 10. Now, this 11 is available in the decimal number system, which is equivalent to 1011 in the binary number system. This is what you need to understand. The same quantity in the decimal number system is represented with 11. The same quantity is represented in the binary number system with 1010. And this is a way of converting the given binary number into the decimal number. Okay. So, this is what you need to understand carefully. For just remembering purpose, I will give the representations here with the 4 digits. So, 0, that means here I am representing with the decimal numbers. This is a decimal number, and here I am giving corresponding binary digits. Okay. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the minimum number of digits I have to remember. Okay. So, with the 4 digits I will give. So, 0 is a 0, 0, 0, 0. You can take single 0 also. You can take double 0, triple 0 or 4 0. So, whatever it may be. Just I need to represent this 15 with 4 ones because it is requiring the maximum is 4 bits, 4 digits. That's why everything I am representing using 4 symbols only. So 1 is nothing but 0001, 2 is nothing but 0010, 3 is 0011, and 4 is nothing but 0, 100, and 5 is 0101, and 6 is 0110, 7 is nothing but 0111. Now you see here carefully, 0 means all zeros I have taken. 1 is this one, 2 is nothing but 0010, 3 is nothing but 0011. Okay. Now you see here carefully 00011011. But for this set of numbers, left side I have 00000000. Okay. Now for the next set, if you observe from 4 to 7, if you see carefully, what I have given here, again same set is repeated 00011011, but the third bit is 1. Okay. Otherwise, next how many bits will be there? These are 8. Here 8 are there. So, these same 8 will be repeated here. But the most significant bit, this last one is called most significant bit. First one is called least significant bit, MSB, and it is nothing but LSB. So, here I have to take this 8 will be 1,000. Next will be 1,001. Next will be 1,010. Next one will be 1011. Next one will be 1100. Next one is 1101. Next one is 1110. Okay. So like this you will get. Next one is 1111. So like this all the numbers have taken. If you observe one thing, all these 8 numbers starting from 0002 to 111 is repeated here. That is what you need to observe. Only the most significant bit is changed from 0 to 1. Next numbers have been obtained. This is the way of writing the numbers in the binary number system. Same thing we are following in the decimal number system also. So, what is the reason for giving this set of numbers means these are the minimum number of conversions you have to remember by default. Okay, without manual effect, you need to understand what is 10, 1010, what is 13, 1101, what is 15, all ones, that means 4 ones, and what is 0, 0000, what is 7, 0111. So, immediately you should able to use these numbers directly. Okay, 0111 means immediately you need to tell it's a corresponding decimal number, that is 7. Or if you ask what is the corresponding binary number for the related 8, 8 means 1000, like that immediately you should able to tell, or immediately you should able to get the value for your remaining calculations. Okay. So, try to remember all these values. With practice you will get easily. Now you see binary to decimal conversion, just now we have done. Steps also you can see very carefully. Write the binary number, multiply each bit with its positional power of 2. Okay, 2 power 0, 2 power 1, 2 power 2, like that we have to write starting from the right side. Add all the values to get the decimal. Here another example we have taken 1101. Okay. So, this one is multiplied with 2 power 0. That means 2 power 0 is 1. So, 1 into 1, that is representing this part. Now, this 0 is multiplied with 2 power 1. 2 power 1 is 2. So, 2 into 0. Next, this 1 is multiplied with 2 power 2. That means 4. So, 1 into 4, that is this part. Next, this is multiplied with 2 power 3. That means 8 into 1, that is this part. Okay. Here 8 we are getting, plus 4 is 12. It is 0. 12 plus 1 is 13. That means 1101 is representing 13 in the decimal number system. So, this is the way of converting given binary number into decimal number. Now, decimal to binary. Now, it is reverse case. So, first I will tell one example, then we will see the steps here. So, here they have taken 13. So, same thing we will take here, 13. 13 is available in the decimal number system. Now, I need to convert this one into binary number system. What is the base or what is the radix for the binary number system is 2. Okay, base or radix, that is representing how many different symbols we are using in the corresponding number system. So, 13 is in the decimal number system. You take 13 like this, divide this one with 2 because we need to convert this one into binary number system. When you divide like this, 2 6 12. So, what is the remainder? 1. That remainder you write here. Then, what about this one? 2 3s again divide with 2. So, 2 3s is 6. Completely it has been divided. So, its remainder will be 0. Now, here 3 is there. Again you divide with 2. So, 2 1s are 2. So, remainder is 1. Okay. So, you need to continue this particular process until you are getting here last one is 0 or 1. Like that you have to do. So, now you start writing these values from last part to the starting part. That means what did you get here? 1, this one I have written, next this one I am writing, next this 0 I am writing, next this one I am writing. So this is nothing but your binary number related to this 13. So 13 in the decimal is equivalent to 1101 in the binary number system. This is the way of converting. So to convert this binary into decimal, what we have done? We have taken the sum of the multiplicated weights we have taken with the corresponding digits. This 1 is multiplied with 2 power 0, 0 is multiplied with 2 power 1, this 1 is multiplied with 2 power 2, this 1 is multiplied with 2 power 3. So all those things we have added and the result we got 13. And how to convert a decimal to binary means this division process we have to follow. So this is the way of conversions from binary to decimal and decimal to binary. So here some steps they have given, whatever we have done, same thing will be there. Just I will read out this one, you see carefully. Divide the decimal number by 2, okay, and write the remainder. Repeat until the quotient becomes 0, okay, or 1 also. And binary number is equal to remainders read from bottom to top. You see, how did I write this one? From bottom to top you have to take, not from top to bottom, that is wrong. So example is 13 in decimal is equal to 1101 in the binary. Now, some examples we have to perform here. Convert the following 10101. This is in binary, should be converted into decimal. Okay. So here I am taking that one 10101. I need to convert into decimal. For that, what I need to do? Its weight is 2 power 0. Its weight is 2 power 1. Its weight is 2 power 2. Its weight is 2 power 3. And its weight is 2 power 4. 2 power 4 is 16. 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 2. And 2 power 0 is 1. So, just multiply with the weights. So, this 1 is multiplied with 16 plus 0 is multiplied with something will be 0. But this 1 is multiplied with 4. The 0 is multiplied with 2, but that is 0 only. 1 is multiplied with 1, so that is 1. Okay. Now what will you get? 21. So this 10101 in binary is equivalent to decimal number, that is 21. Okay, 10101 in binary is equivalent to 21 in the decimal number system. So this is the way of converting. Okay. Now second one we will do. What is the second one? 10000 they have given, which is in binary number system. So we have to know about the weights. Its weight is 2 power 0, its weight is 2 power 1, its weight is 2 power 2, its weight is 2 power 3, its weight is 2 power 4. Okay. Anyhow, all these things are zeros only. 1 is multiplied with 16, you will get 16 plus 0 into 8 is 0. 0 into 4 is 0, 0 into 2 is 0, 0 into 1 is 0. So it is equal to 16. That means 1 4 zeros in the binary is equivalent to 16 in the decimal number system. Here I want to mention one thing. Okay. What is that? You see, 2 in decimal is represented as 10 in the binary. Next, 4 in the decimal is represented as 100 in the binary. 8 in the decimal is represented as 1000 in the binary. 16 in the decimal is represented as 140 in the binary. 32 in decimal is represented as 150 in the binary. 64 in decimal is represented as 160 in binary. You see here, as 2 power we are increasing. It is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. If it is 2 power 6 in binary, we can represent easily like after writing 1, you have to take 6 zeros. That means 2 power n, if you want to represent in the binary, what you need to do means after writing 1, here number of zeros will be n zeros you have to take. Okay, n zeros you have to take. That is a representation in the binary number system. It will be helpful to you. Okay, while calculating the things or in the problems, it will be easily helpful to you. That's why I am telling here. So it is 2 power 2. That's why 1. After 1, we are writing 2 zeros. It is 2 power 3. That is 8. So after 1, we have to write here 3 zeros. 2 power 4. 1. After that, we have to take 4 zeros. So it is an easy way of writing here. Okay. Now we will see another one. That is 25 in the decimal is to be converted into binary. That part we have to do. Okay. You see here, what is the procedure we have to follow? Division procedure we have to follow. So 25 is to be divided with 2. That means 2 12s are 24. Remainder is nothing but 1. Then 2 6 are 12. Remainder is 0. And 2 3s are 6. Remainder is 0. And here 2 1s are 2. Remainder is 1. So we have to write from bottom to top. What will you get here? 25 in decimal can be equivalent to 11001. 11001 in binary. So like this we can able to convert now decimal to binary. One more method I will tell here to solve this one. As per our previous discussion, this thing you can able to write as a sum of the two numbers. One number is related to 2 power n. That means the nearest value which is related to this 25, which is close to 2 power n, is nothing but 16 I can take, because 16 is 2 power 4. But if you take 2 power 5, that is 32. That is larger than this one. That's why I am taking here 2 power 4, that is 16. 16 plus 9 I have to take now. Okay, then it is equivalent to 25 only. 16 plus 9. Now this 2 power 4 I can write in the binary, that is 1 4 zeros. Then this 9 can be written in the binary, that is 1001. Okay, I need to remember that one. That's why I have given all the 15 numbers in the beginning. So 9 is nothing but 1000 means 8. So 1001 is nothing but 9. So this 140 is representing 2 power 4. This 1001 is representing 9. Just add this. Cut 1 0 0 1 1. You see the same result we got. Where you are getting this one or this one. It is the shortcut method. Okay. So this 25 I am writing like 2 power 4. That means 16 plus 9. What is the requirement of that one? Why did it take 16 plus 9 only? I can take 24 plus 1 also. Okay, but why did I take like this means I know how to write this one 2 power 4 directly in the binary. Because it is 2 power 4, after one I can take 4 zeros easily. So that if you take 9, that 9 if you add, you will get the directly this related binary value you can able to get. Okay. Then now the last one is 17 in the decimal is to be represented in the binary. First you will see the standard method. 17 is to be divided with 2. So 2 8s are 16. So remainder is 1. 2 4s are 8. Remainder is 0. 2 2s are 4. Remainder is 0. And 2 1s are 2. Remainder is 0. Okay. So write from bottom to top. Then what will you get? 17 in decimal is equivalent to 10001. 10001 in binary number system. Now this is a solution here over, but in the shortcut method also we will see, that is 17. 17 can be written as 16 plus 1 and 16 is 2 power 4 plus 1. Now in the binary 2 power 0, 2 power 4 can be written as 1 4 zeros. Okay, here just 1 is there. So what will you get? 1 0 0 0 1. It is nothing but binary representation of that 17. So same answer we got in both ways. Okay.